Okay, hello everyone. This is a talk what just happened in my cluster, and basically I'm gonna walk you through on our journey, how we've combined observability, security with a pinch of AI, of course, and managed to achieve something that I think can be kind of useful. Well, hi, my name is Arina. I'm a DevSecOps Engineer at Money.com. And Money.com is a company that builds a work OS platform that combines multiple products. Basically, on this platform, we have 4 products that help you and your organization run your things, the tasks, the projects, whatever you have. So let's get into it. First, I have a question. How many of you guys have access into your Kubernetes clusters and you can run kubectl exec there? All right, so that's a lot of people, and we have this as well in our company. Either we as infrastructure engineers can request admin access for some time and basically become admins, or our developers can create something called a dev pod. It's not the one that's in CNCF. I'm not sure who came up with the name first, but what a dev pod is a copy of the production pod that is running in production, but the difference is that it doesn't serve real human traffic. So it's isolated, and it typically used during the incidents when the observability that we have is not fully enough. Imagine like the incident itself is quite stressful. So I think a lot of you might think of it as something problematic. At least we think so, especially in the DevSecOps team. And like I said, it's there for historical reasons. It's used during the incident. So we faced a bit of a pushback while we were trying to get rid of that. So we decided, well, if you cannot beat them, let's just lead them. And we decided that we want to provide the guardrails and some observability into what's happening inside of those pods. Also, some of our development teams, they wanted to know what other teams might want to see inside of those pods in their namespaces. And before we get into the solution, the problem, I want to take a step to the left and tell you how we access the Kubernetes clusters. We have something called SOX audit, and because of that, some of our access has to be recorded. So because of that, we use a tool called a teleport. A teleport is an identity-aware tool that we use with the SSO provider, Okta in our case, and what happens is our employee logs into the Okta, then the teleport sees the Okta groups that this user has, and then based on those, either it can or cannot log into the cluster, but what you have on the outcome is not only a happy, allegedly happy employee, but also a recording. It's either in a text and video format, and given the solution, the problem that we have, we decided that well, since we already have the recording, it sounds like something that we could reuse to solve the issue. So now, the solution itself, what we have is the Lambda that is running actually every 30 minutes, not 15. It pulls the recordings from the teleport in the text format. It runs some extra processing on top of that. We see only the content that the person is performing, everything that you have after you type in kubectl exec. And then it's being sent to the AWS Bedrock with the basic prompt that we have. It's like, so you're this super cool security engineer, you know this, and that. This is what we have. What do you think about it? What was the context? We have the MCP, that internal one that's connected to it. And it's quite generic, as you may know. So we still had some questions left after that, and we wanted to know what development teams think about. So this happens in your domains, in your pod. So tell us more. And of course, since we're kind of like, we're getting bigger, we wanted to scale it, and we gave the teams the ability to have their prompts being plugged in. So imagine your project manager or the product owner, whoever, can just create the prompt, and it's being plugged into the Lambda that we have. So in the outcome, you get not only answers to your questions, but also there. So it's all being pushed to the S3, then to our long-term login solution, and we can trigger events based on the prompting. So what it looks like, I don't know if you can see it very well. It's very redacted, but we see the user, we see the content, we see the time. We see something called AI inside is basically something that we wanted to achieve, and you can see here on the very top the Cypher security. This is exactly the main prompt. Cypher is one of our teams, so they have a list of prompts, and in the end they're alerted based on if there is something suspicious that they notice. So this is great, this works, and we already have it running for quite a while. We're happy with the solution, but I'm just gonna show you what was the other option for us to do it, what we explored, and why we decided to not go that way. So I think a lot of people here are already familiar with eBPF, and probably you see the logo. This is the logo of the BPF, and you might get the answer. For those who are not familiar, if there are any, I'm not going to ask the question. So the eBPF is a technology that lets you run the applications within programs within the kernel level without you having to extend the Linux kernel source code or load any extra modules. And it's quite fast and it's very, very powerful, especially given that it also can work with Linux security modules, which help you restrict some access in real time. So the programs that I mentioned are ran based on the hooks. The hooks can be network events, or they can be what's in my opinion like kind of cool, and the most useful way is that practically any kernel function. And like you know, everything that we do is a kernel function. So is it possible what we wanted to achieve with it? And the answer is, of course, yes. Right now you're looking at the tracing policy. This is the CRD of the tool called Tetragon. This is an open source tool which is part of Cilium, and we managed to achieve with this policy exactly what we wanted. What it does basically, it hooks into the kernel props. It's the syscall of the syswrite. It sees everything the user entered, and then it records it. So we get the context, we get what we wanted. And we decided to not use that. We decided that's not what we want exactly. So we have quite a lot of tools that are eBPF sensors. We use eBPF extensively for networking, security, monitoring, practically like all the most common spheres. And what we know and what's familiar in the community that eBPF is kind of prone to the denial of service. We already had some history with it. So this was the main reason, especially for the syscall like syswrite, which happens quite often. We decided to not do that. So with all that, I just wanted to conclude that we've gained in the conversational format, the visibility into what happens into our clusters. And we gain not only just the comments that users perform, but also some context about it and something that we can really use not only us as software engineers or infrastructure engineers, but also people that are not very familiar with the domain running. And that's it. Thank you very much.